Thanks. Hi, I'm Mircea, and I hope you are hearing me very well. No? Is it turned on? Better now? Cool, thank you. I'm very happy to be here in front of you. It's a great privilege to be here again. I'm representing DigitalOcean today, and this is going to be a pretty long session. It's going to take about 1.5, maybe up to 2 hours, including questions and everything else that follows after. It's going to be a tutorial about how you can extend a tool called Salt, how you can extend it in your own environment for developing your own features and capabilities for network automation, more specifically for event-driven automation and orchestration. I will walk you through very briefly an introduction to Salt if you are not familiar yet, if you haven't used the Salt before, just very briefly to get an idea. I won't go very deep. After the first few slides, I will link some resources where you can go on and read a little bit more. Then I will present some new features that have been added in the latest Salt release that are available natively just by default. Then I will present the tutorial or the live demo setup. We are going to, what I'm going to show you, but also I will give you access to several DigitalOcean droplets from where you can manage some virtual machines provided by Tisuto. Then I will present how we can, the very first steps, how you can write your very first module in Salt, then how you can cross-call different functions, then based on mainly on the latest features from the 2019.2.0 release, some functions that you can use for low-level API calls that allows you to interact directly with the network device. Then how we can use these low-level API calls to write your custom modules for interacting with the device and getting and configuring various features. Then cross-platform implementation, so we can implement the same functionality, at least from the perspective of the CLI, and how can we implement it cross-platform. So say if you have Juniper, Cisco, and how many other platforms, you probably want to follow the same methodology for all of them and not something treating them as separate entities. And at the end, very quickly, how we can use these custom modules that you write in your own environment for event-driven orchestration. Now let's proceed with a short introduction to Salt. Salt is an event-driven and data-driven configuration management and orchestration tool. I personally, I'm biased, and I will say that in my opinion is the most complete automation tool that is available nowadays. However, this comes with a cost, and which requires a little bit more skills, and it's a little bit more complex. But the possibilities and what you can do with it is unlimited. Automation has been introduced natively into Salt since 2016, when a library called Napalm has been integrated and provided different features, just something very basic with interacting with the network device to gather some details like ARP tables, MAC address tables, NTP for BGP neighbors, for routes to show you what routes you have installed on your device and what are the details, and so on. Now, just a very brief idea on how we can install Salt. It's not that complicated. The Salt maintenance provided a script which you can download. Actually, you can do this in one line, but it's safer probably to download, inspect the scripts to make sure that you didn't download something else and the script has been spoofed. And at the end, just execute it and it's going to install Salt for you. A typical Salt architecture is a hub and spoke type, having one master, which is a system service that manages several thousands of Salt minions. These are usually services that are installed somewhere on a server, which of course we can't really do on our network devices, unfortunately, which is why this concept of proxy minion exists, which acts exactly like a regular minion, which is basically just a process that can run anywhere as long as it can connect the master. And also it can speak to your network device over netconf, over HTTP, over SSH, or whatever your vendor is able to provide. Another aspect that we need to keep in mind, SALT comes with a nomenclature that you need to be aware of. Is nothing super advanced, just is some new terms that when you hear them, you are going to need to understand what it means. For example, pillar is free-form data that can be used to organize configuration values or sensitive data. This is usually data that you can manage in your own environment, and for example, it can be files, can be whatever file system, can be YAML, can be JSON, can be whatever you want. Also databases, HTTP API, and so on. It's literally unlimited possibilities depending on what are your needs. And the idea is that SALT works with data, not with standard or what file formats or anything. What it cares about is to be able to fetch the data for you. Then the grains. Grains is data collected by SALT from your network device, is what SALT knows about this device. You don't need to do anything about this, just to be aware that SALT knows this, and when you need it, it has all these details for you. For example, device model, serial number, operating system version, and so on. Later on, we are going to see how we can use these grains for automation. Another concept is this file routes. The way the master communicates with the minion is through a file system that SALT has embedded. The idea is that the files routes is the path from where the master should serve the files from. So, for example, you want to write some modules in your own environment. So the file routes will tell, hey, load the modules from these paths. So it can be one or more. In this tutorial today, we're going to use that path. So, for example, if you put the modules in SRV SALT, it's going to load the modules and other files you may need from there. Similarly, there's something else called pillar routes. As I mentioned, the pillar is data that you provide. So if you provide files, SALT needs to be able to know from where to load those files from. If you provide the data from HTTP API, of course, probably you won't need this, but most of the time it's working. What I'm going to use today is working with files, and from there I'm going to load the data from. And this is about it with this short introduction. I hope you have a better idea if you haven't used it yet. Otherwise, I would recommend you to follow those links and understand better how what it means automation with using SALT. It's a very nice tutorial on the SALT stack docs. Is SALT in 10 minutes just to get some idea and understand better what pillar is, what grain, and many others. Also fundamentals. There's another document of configuration management using SALT, the official documentation for network automation using SALT, and so on. Also, at the end, I have some, actually this one here is a tutorial I had about 2.5 years ago at NANOG, which if you want to watch it. With this said, by the way, because it's a long session, I can take questions in the meanwhile if you want to ask something, so I'm not bothered at all. So anytime you want to ask something, just raise your hand and I will repeat your question for you. All good so far? All right. I will present quickly some new features that are available in the new release Florin in 2019.2.0. For network automation specifically, it's been more than 1 year since in SALT has been integrated feature for Netbox, if you know the IPAM and data center management tool. netbox, and in this release, the community has added many more features. For example, to create circuits, to create, to add a new IP address, to create circuits providers, or to get the interface data in an OpenConfig format, and many, many others. Now, it's been a while since Napalm has been integrated. In the meanwhile, the community has added many more features, not only Napalm, it's not only about Napalm. And in this release, the community has added an integration with NetMiko, which is, if you are not familiar, is a library that allows you to communicate with network devices that don't necessarily have a proper API to interact with, so can just use the glorious SSH screen scraping. Similarly, it's been added a feature for interacting with Arista switches directly using the PyEAPI library with Cisco Nexus. Again, because it's HTTP based, it's just very easy to interact with them. Also with other libraries such as Cisco Conf Parse, which is a library that the community appreciates in general for parsing Cisco-like configuration text, which is not structured or something that you can easily process. And this library allows you to ingest that text and analyze the configuration as in a parent-child tree structure. For Napalm specifically, the support has been continuously improved. And now for any platforms that are integrated in Napalm, that being native, the native drivers for Juniper, for Cisco IO6R, Cisco Nexus, and I don't know what else. There is Arista, API, and so on. There are many others that are supported by the community, for MikroTik, for I don't know. There are many. And the idea is that now in Salt you can have something that the community demanded very often, to be able to commit at a specific time, or commit or revert a commit, and so on. So if you are going to Salt, doesn't matter that your device doesn't support this. For example, on Cisco IIS, we don't have this feature, but going through Salt, you are going to be able to have all of this. So you can say, I want to apply a configuration change, but revert it in, I don't know how many minutes or later at a specific time, and so on. Okay. For Juniper has been an integration and several functions such as napalm.junos CLI. We're going to see some more concrete examples a little bit later, but now just to remind this function that allows you to execute a CLI command directly on the device without going through anything else. And similarly, an RPC call. Why is this important is because it interacts directly with the device, so it gives you unlimited possibilities. So whatever you can do on the command line, you're going to be able to execute all of this direct to Salt without any other things. We'll see later how powerful can this be. Exactly in the same way, through NetMiko, just executing commands such as napalm.netmiko commands and show versions or show interfaces, and a list of other commands that you can usually execute on the command line of your network device. You're going to be able to execute exactly the same through Salt, and gives you back the exact output you would normally get from your device. In the same way as another one, napalm.pyeapi run commands, and you can run several commands, show versions, show interfaces, and so on, that give you back the output you would normally get from your Arista switch, either as text or as a structured JSON document, which you can then process further and just extend the automation depending on your business logic that you need. I won't insist anymore on this, but also with Cisco Nexus, you can do exactly the same. There's a new function named napalm.nxos API show, and you can enlist several commands like show BGP sessions or show processes that are going to give back a structured output for each of these commands. And another one, I mentioned this library Cisco Conf parse. There's another integration that you can access directly through your napalm proxy minion, which is called, for example, one of them is config lines with child. For example, is going to ingest a Cisco-like text-based configuration. And if you execute this command interface and shutdown, it's going to show you all these interfaces that have shutdown applied on them. Now you may be wondering why I said that you can execute on any command, but you don't need the napalm anymore. The idea is that all of these start with napalm.something just because it's sometimes easier to reuse the connection credentials from the existing connection with napalm, so you don't need to reapply them over and over again, just reuse what is already there. Otherwise, if you don't use a napalm minion, of course, you can use this without anything else, just provide the credentials along with the rest of the arguments. Why I presented all of this is because we are going to reference this, or at least some of these functions, actually most of them, in the next examples. And they are going to help us to extend the SALT by executing them, because they are the functions that allow us to interact directly within a device. Now, today I'm going to have a live demo in this tutorial, and I will have a DigitalOcean droplet, a virtual machine server, where I have a SALT master and 2 proxy minions, as you can see in this image. Each of these proxy minions is managing a virtual machine, one Juniper VM and one Arista VM, both provided by Tesuto, so thanks to them. So it's not only going to be me today doing all of this. I also have prepared 10 servers for you if you want to do this live together with me. And we'll have exactly the same setup, just a small change, which I'm going to mention. So right now I'm going to ask you who would like to do this together with me. Okay. I have some files to share with you, so with the instructions. So. Okay, so due to limit of resources, I only have 10 of these, so if you would like, you can group together and stay together and watch while doing this. I provided the instructions, so there are 6 steps over there, and the first step is to connect to one of these servers. So you can just SSH salt at SRV1 or SRV2 and so on, .automate the .net, and the password is provided on the documents. I'm going to wait a little bit. You are going through this. Another thing to mention is that on each of these servers, there's already a SALT master running. and each of you is going to have one proxy minion for the Junos VM and another proxy minion for the Arista VM. And similarly, each of you has a pair of Arista VMs already running on the Tesla cloud. Has anyone been able to SSH into the server? Please raise your hand. So just to know. Okay. Cool. Should I wait a little longer? Is anyone that hasn't succeeded? Okay. And from this setup, you are going to be able to execute various commands. So what I'm going to do, I will switch right here to my terminal, and I will do the same like you did. And I'm going to jump into a separate server, which is only mine, but with the exact same setup. Has anyone seen this? I mean, are you able to see what the terminal is displayed correctly? Cool. The next step on the paper is after you have successfully logged in, is to start your first proxy minion, firstly in debug mode. So I'm going to do this myself too. So you have there SRV1. For SRV1, you have Junos 1 and EOS 1. SRV2 have Junos 2 and EOS 2, and so on. I don't have this number, so I'm going to just start straight away. Starting the first one, the Junos proxy minion in debug mode. You can see it's very verbose, is collecting a lot of data from the device. It looks good. If you are seeing, if you got to this point where it says lazy loaded mine.update, it means it's starting correctly, and even more if you are seeing an XML document displayed like that, it means that it's been able to fetch data from your proxy minion. So I'm going to remove, firstly to stop it with Ctrl+C, just stop it, and then start it in daemon mode to be running in background. I'm going to do exactly the same with the other one, with the EOS one. Just to mention, if you are following together with me right now, make sure you are starting with the proxy minion ID that's been assigned. So Junos 1, EOS 1, Junos 2, EOS 2, and so on. So just to make sure it's clear. And the same for the EOS proxy minion. You should see a lot of text, including that the proxy has been able to successfully fetch various data from your proxy minion. It looks okay, so I'm going to put this one in background as well. Now to check that the both are up, have been accepted by the master, you can execute this salt key capital L, and you should see EOS and the Junos. That it means that the salt master is aware of these two minions, EOS and Junos. And with this said, we can start and execute commands. One of the simplest one is test.ping, and which is literally just saying that, hey, is this one up? And if you do salt star, make sure to escape the star, otherwise you can wrap it around the codes like that to ping all the devices that the salt master is aware of. In the exact same way, you can proceed and execute some other commands like net.arp, which is going to retrieve the ARP tables from these devices from Junos and from EOS. As you are looking into this example, you should notice that the structure, no matter if it's a Juniper or an Arista switch, it has the exact same structure, the document you are getting back. If this is not clear enough, let's say want to display this as I don't know, YAML document instead of just a default style that is displayed on. So you just append out equals YAML, or I don't know, there are many other formats. I think let's try this one, table, which is going to display you, can't see really the colors here, but it displays the ARP table as a property and so on. There are many other output styles you can use to display the data you have. Similarly, you can, if you want to look at the LDP neighbors, it's the same methodology, meaning that no matter if it's a Juniper or an EOS switch, the data is represented in the exact same way. As I was saying at the beginning, the idea is to work with data, not with data, you know, to focus on this is a JSON or this is a YAML. No, you are focusing on using data. Okay, back to the slides. You should be able to ping both devices and execute random commands. Let me provide another example. For example, root.show, that, let's say, .0.0, that should show you the details of the default root on both of these devices. Before going further, is anyone that hasn't succeeded to start the proxy minions and to execute this, exactly this does the ping? Anyone? Good. Now, if you are going to follow these steps offline, or if you want to do it right now together with me and didn't get one of these servers, you can do it, just that you are going to need to have Docker installed, and the instructions are shared in this GitHub repository right here. Now, let me present you what is on those servers. The SRV salt path is a symlink to home salt NANOG 76, which is a Git clone of the GitHub repository I mentioned. So nothing else. If you look into it, you're going to see that it has a bunch of files, including two directories named xmods and pillar. Into the pillar is we are going to have the pillar files where we define the pillar data, and into this directory xmods is where we are going to have the extension modules that are going to be explained a little bit later. So that means so for Salt to be able to identify where to load those files from, we're going to have this file routes, this path specified to the file routes. You don't need to do anything, this is already done. You have this on your machines, just that to be aware what's going on over there. If you are using Docker, is anyone that wants to follow with me with the Docker installation right now, or should I skip? Probably not. The idea is just edit two files. After you clone the repository, have this file Junos pillar and EOS pillar. You simply just edit this hostname to point to a virtual machine or a real device that you have together with the username and password. So the proxy is going to start up. So after that, you just execute the make up with the proxy ID, and should start for you two containers from where you can start executing arbitrary commands. That being said, we now have the Salt environment up and running, so we can start looking into our first execution modules. One first example is this file, which you can find under xmods modules example.py, which I'm going to open it just right now. So I'm going to this directory, and then into the X modes. Under these X modes, we can see, hopefully, you can see there is a module called _modules. It is a directory, sorry, called _modules, where we have the extension modules. This is the path from where Salt is going to load the modules we provide ourselves in our own environment. If you look into this directory, you should see the files that are available into the GitHub repository. So first one is example.py. Here is this function named first that doesn't do anything else, just bells out and returns true. This is what I have here on the slide. Immediately after you edit a file, for Salt to be able to know that you have edited this file, you have to execute the sync modules, but as you just started the proxy minions, it loaded this, so you don't need to do anything else right now. So you can just go ahead and execute. I'm going to do this example.first, which, as you can see, it returns the output from the function we've just defined. So this so far is very easy. I just wanted to show how a function that you defined is loaded and executable. Why you are executing example.first? It's easy because the module is named example.py and the function is called first. So what you're going to execute from the command line is example.first. So module.function name. Now, Salt comes with thousands and thousands of functions you can use out of the box. And the nice thing is that you can reuse this. For example, you want to execute something, get the output, and then process it further. You don't need to do a dumb thing like write in a file, read the file, write again a file, and so on. You just invoke it as a simple Python function, and you can cross-call it like that with _salt, then you can reference the function name. For example, if we, there's one of the functions that are natively available is salt test.false, which surprisingly returns just false. And the other one that we've just defined earlier, example.first. And this is how you can cross-call it. So I'm going to do this right now. I'll switch back to my console. And then executing example.second. I actually think I'm invoking test.true. And example.third, again, everything is true because it's actually invoking example.first. Now, let me open this to show you. Example.second invokes test.ping. And the third one, example.first, which is the other function defined just here. You could, of course, just call first directly without anything else, but I thought it would be a nice example to see like that. The same way, when you edit a file, a new module, when you add a new module, or if you edit an existing one, you should execute the sync modules. Right now, no, because as I was saying, the files were provided there already just before it started. So to make things more complicated, I'm going to edit this file, test.false. So the second function is going to invoke a different function, test.false. As we are saying just here, example.second returns true. So now I'm going to execute salt util.sync modules. You can see the output that it said, hey, modules.example has changed. And this is the same output from both of them. So now when we are executing example.second, you can see that the output has changed, and which proves that is invoking a different function right now. and with different output. For interacting directly with the network device, as I was mentioning at the beginning of this talk, there are many low-level API call functions. For interacting with Junos, there are these functions, just to mention a few, napalm.junosrpc, napalm.junoscli, and napalm.junoscommit if you want more specific properties for commit. For example, if you want to commit with a message, or I don't know what other features Junos specifically has and other platforms don't have. For Arista to run commands, PyAPI run commands, and PyAPI config to manage configuration on Arista switches. For Cisco switches, napalm.nxos API show and napalm.nxos API config. The first one show is for show commands, in interactive commands, while the second one in NXOS API config is configuring, is providing configuration on Cisco Nexus switches. And any platform supported by NetMiko, including the above, if you want to interact via SSH, can execute commands like show commands, but also napalm.netmiko config to configure via SSH. And I'm going to go through several examples, starting with the first function, napalm.junoscli. Excuse me. For example, if you execute napalm.junoscli and command such as show validation statistics, your Juniper router is going to return you the exact output as you'd get normally when you get from the CLI, right? So you have this CLI output from show validation statistics. Now the nice thing is that if you put at the end of this command format equals XML, the output is going to be different and is going to be structured as a nice document. Is displayed like that because this is how it's displayed on the CLI, but this is actually just a Python document. And I'm going to show you here. If you put at the end out equal row, see here this CLI option. Oop, too far, sorry. You are going to see that the previous output is nothing else than just a Python dictionary that if you invoke this function, you are going to be able to take this output and process it further. And I will switch now to my console, and let's say I want to execute on my Junos, napalm Junos CLI. Something like a show version, because it's a Juniper, is a virtual machine. I don't have something like validation statistic, which is for RPKI. Of course, I don't have this on a virtual machine. And executing napalm.junos CLI show version is going to show you the usual output you normally get from the console. Appending format equals XML. You're going to see that the format now is a structured document, which has all the information that you have in the text-like document, but you can access them easier because, for example, let's say if you want to display out equal row, you are going to see that is simply just a Python dictionary. So if you want to take this output, you would simply do a lookup and say, look under the Junos key, then the message key, software information key, and so on, if you want to get something, some detail. I will have a very specific example for that in just a now, if you want to execute this example I'm doing here, you can feel free to do it. I actually quite encourage you to execute random commands like that you want. I mean, it's good for you to get hands-on. And in the meanwhile, let's go to the next function named napalm.junosrpc. Juniper has this concept of interacting with the device through and get different data through RPC calls. This is how it works internally. And if you have a command like we had previously, show validation statistics, if you append at the end display XML RPC, it's going to show you a document like this. Here with blue color, I put the RPC name. So here it says that this is the RPC ID that is that Juniper is identifying this command. So when you execute on the command line show validation statistics, what Juniper does behind the scenes is nothing else than invoking this RPC. So we can do the same in Salt. You can directly invoke RPC commands like that. So napalm.junos RPC using the RPC ID displayed earlier is going to give us the document we've seen a few slides back when executing the CLI command. Just now is directly going to execute using the RPC. So Juniper is not going to go through and identify the RPC and then execute, so can directly execute. And this is a better way of executing than the CLI, because the CLI is not always preserved across versions or across platforms or I don't know what other mess, while the RPC generally is pretty much the same. So using the RPC call is a better idea. Well, now the next one is this PI API run commands. Here's an example from an Arista switch. If you execute napalm.py API run commands and a list of commands, this one accepts one or more commands. For example, show version is going to show this output. Again, it's a structured document. It's just displayed like that on the command line with all the details. Let me do this myself too. So salt EOS and napalm.py API run commands show version. You can see this nicely displayed here, and if you want to convince yourself that is indeed a structured document and not a wall of text, you can see it with the raw outputter, which displays you that is indeed nothing else than a Python dictionary from where you can very easily extract the data. The same goes on with a different command with napalm.netmiko commands, and which goes via SSH and executes arbitrary commands. The advantage of using this method is that you can use it on almost any platform you have, because it goes through SSH. So as long as your platform can do at least SSH, you should be able to use netmiko. So, for example, if you execute show version, and let's do this right now. Netmiko commands. Is going to show you this output exactly collected from the command line of your device. So is the way you would normally execute on your Arista switch. If you would jump into an Arista switch and execute this, it's going to show you this. The disadvantage with netmiko commands, however, well, in some cases is the only option, but is that it gives you only text back. So you'll need to process the text, as in opposite to the previous examples where it gives you a structured document from where you can load data very easily. Also, it's a big win on even on Juniper switch, Juniper operating systems that don't have all the commands covered with RPC calls. For example, if you want to execute an MTR, I personally had this need in production to collect dynamically some MTRs. You can't do this, so just an SSH screen scraping is the only thing you can do, and executing this traceroute monitor with all the details, NetMiko is going to be a big help. On Juniper as well, for example, you can't get system processes and some other things. So we can use this as a general rule if when the API is not available at all, or it is available but is kind of limited, maybe NetMiko commands is going to help. In the same way, you can configure, let's say, napalm.netmiko config and throw some config lines. Is going to configure your switch. Or on Juniper, again, you have this netmiko config and throw some config lines, and is going to configure the network device in the way you do, just via SSH. It's not a good practice, but sometimes it's the only thing. On Juniper, however, there's another thing you should do is to pass explicitly commit equals true, because otherwise it's not going to apply the configuration change. Any questions so far? I'm going to pass to the next section. It's about writing modules for network automation. In this section, we'll need to know very well what we've been speaking previously, that being how you can invoke cross-call execution modules, but also how you can execute direct API calls. So let's take this example of the show version on a Juniper router. You can do show version and display XML, and this going to give you back all this document. From Salt, you can execute this. The equivalent napalm.junos CLI with show version and format equals XML, which is what I'm going to ask you to do together with me. Actually, I did this before, previously, but I will do it again. So it's napalm.junos CLI followed by the CLI command you'd normally execute, show version. Make sure it's wrapped around quotes or double quotes. And then format equals XML to ensure that is going to pull out an XML document and then process it. And at the end, optionally, if you want to display it as a raw Python object, or otherwise just leave it without to display it nicely on the CLI for a more human readable format. What you should notice here is that it has this message key under which you can find software information, and then host name, and also there's another one here, a key named Junos version, which has the version of what this virtual machine is running. Which is why we can go on and write our very first extension module, which cross-calls this function, napalm.junos CLI, is here under salt, and the exact command you are going to execute, so it's show version. And also other arguments, exactly like we have on the CLI, is translated into code here. As you can see, is a one-to-one mapping, is nothing really complex. So if on the CLI you execute napalm.junos CLI, into the module, you call it that, pass the arguments, and from there, everything boils down to just looking into this document. So the output from this function is a Python object stored into this variable ret. And into this variable ret being a dictionary, you can directly look up ret message, this is the first key, then software information and Junos version. And under this key, you should find the Junos version. So let's look into this exact output here. you can see that it has message, then software information, and somewhere, probably somewhere at the end here, because there are many, many details Juniper provides, is Juno's version, which is the key with this version. So let's go ahead and execute this function. Is example.Juno's version. The code being that one exact from the example. So if you do Juno's version, does exactly what I did on the CLI previously, and then processes that document and extracts the data we are looking for. Yes. Yes. The question was if what it does behind is taking the output from the device and doing a lookup and displaying the key. Is that correct? Yes, exactly. Because maybe you were wondering what is this format equals XML. It means that it requests the device, hey, give me an XML document. And from that XML document, we can easily extract values. It's actually what it does. The PyEZ library is based on that. It takes that XML document and transforms it into a Python dictionary. This is it. So it's a one-to-one mapping. Not exactly, yes. The device is exact. No. This one is Juniper and returns an XML document. Yes. Happy case. Right, so is anyone that didn't get here? Everyone executed example.Juno's version. Okay. This is the execution. Now, for the next part of the tutorial, we're going to look into implementing features for mixed environments where I have multiple platforms, so not only Juniper. And how you can do this is, one of the methods is depending or relying on the grains. I was mentioning at the beginning that grains is data that Salt collects from the device, and you don't need to do anything about it, just to be aware that it's there. One of these grains is OS. So let's take a look how we can do it. So grains.get OS, and in this case is quite straightforward. It says this function, give me the grains named OS. There are many other grains. For example, you can display them with grains.items. It shows you the uptime of the device, version, I don't know, many other things. For example, the list of interfaces and host name and so on. How we can access these grains is through another special variable named grains __ grains __, and which is globally available into your modules. And from there, just doing a key lookup, say I want the OS grain, just do as I have here in this example, say I want, give me the OS grain, which is at this key. And for this example, and to my example module, I defined a very quick function named OS grains that returns the content from there. So let's do this example.os grains and returns the information you have in the OS key of the grains. As you can see, here is the Junos says that this proxy minion is managing a Junos device, and this one is managing an EOS device. In this case, it happens that the ID and the platform name is exactly the same, but the platform name can be anything, while this one will always be the same for Juniper, and this one is going to be always the same EOS for Arista switches. And this is about it. This is about grains. Just be aware that they are there and you can use them. For example, for implementing cross-vendor features. Let's extend our example and have a more complex function named version, where we're going to use this grain to define something more interesting. And the idea is that if you're running this function against a Juniper or Arista switch or Cisco Nexus or Cisco IO6R, you probably want to have the same syntax. So you want to execute example of the version against Juniper, against Cisco, against anything. So your users are not confused. Hey, I want to, this is a Juniper, I have to execute this command. This is a Cisco Nexus, I have to execute this one instead. This is not how operations should be, and your tooling should abstract away these differences. So, of course, it's going to be much easier to switch between different platforms. And how you can implement this in code using these grains, you can do a lookup and say, hey, if this is a Juniper device, execute this part of code. And then it goes here and says, hey, this is a EOS device, execute this part of code. And finally, if it's a Nexus, execute this part of code. So let's break this down into different chunks. First, let's look at the Junos. So when this function is executed against a Juniper device, the grains are going to be evaluated, the OS grains, and says, hey, this is a Junos. I'm going to execute this code I've seen previously. So this is exactly what I've had into the code just a little bit earlier. It's exactly the same, napalm.junos CLI, show version, format XML, and then do a key lookup to get the exact version. Later on, okay, this square thing is not properly displayed. The idea should be a little bit more south. So when this function is going to be executed against an Arista switch, it's going to say, hey, now I have to execute this command. I have to execute this code. And what it does, it's invoking the PI API run commands function with the show version, which you've seen previously from the command line. And similarly, it then does just a simple lookup and say, hi, I want to look in from this output. I'm going to look under this key, under the version key. So just to make sure this is clear enough, I'm going to execute the CLI command with raw output. It's just here. So it's napalm.py API run commands raw version with raw output, which, as you can see here, is a list. Which is why you have to, why is it the list? Because this function can accept more show commands. So for example, you want to do show version, you can do also show interfaces. Oop. And not with raw output. For example, you can display the interface statistics. There's a lot of data here. The idea is that you can execute multiple commands, show commands at once. Now let's focus back on the show version one. And as I was saying, it's a list, which is why, depending on the order of the command you are invoking, you then need to do a lookup to the specific location in this array of outputs. And this array of outputs contains, is again just structured as Python dictionaries, which have different data. One of them being, okay, found it just here, is the version. So when you want to extract the version detail, you will need to do a lookup under the key 0 it's here, then look under the version key. In the exact same way, with Cisco Nexus, you would execute, you would cross-call this function NXOS API RPC and call the show version function, and then you again do a lookup at the first item at index 0, from where you look under result body, sysverse string, and so on. This again requires to actually look at the raw output you get from the function, and then you decide, hey, I need to look under this key. And as you can see, this is pretty much it. Nothing really complicated. It just relies on executing some commands, looking at the raw output you get from these functions, and then just a simple dictionary lookup. That being said, let's execute our command against both Arista VM and Juniper VM at the same time. Which returns us says that the Arista switch is running 4.21 version and Juniper is 18.4. The most important takeaway from this is that, as you can see, the CLI command is exactly the same on both cases. What it does behind doesn't matter from a user perspective. You just want, I want the version, right? And it's here. I don't care, I don't need anything else. I don't care I'm running against a Juniper or anything else is there. Now, this code here can get a little bit tedious sometimes when you deal with a number of platforms. This one is a very simple example. I've just used it as to be easier to be understood, but it can get more complex sometimes. And in that case, you can follow this procedure, which I exampled with if, elif. If it's a Junos, do this. If it's a Arista switch, do this, and so on. A different alternative, which is a unique Salt feature that Salt has, is overloading the same namespace, module namespace. Other tooling on the market don't have this yet, although they've been around for many years. You can, for example, say, hey, if this is a Juniper, load this file. If this is an Arista file, is an Arista switch, load this file and not this one, and so on. This is called a virtual module. You can say this file should be identified using this name and not its exact file name. So they can be different. You'll see exactly what I'm talking about. And in this regard, I have 3 files here. One of them is platform_Junos for Juniper. One is platform_Arista for Arista, and platform Nexus for Cisco Nexus. But from the CLI perspective and from anything else within Salt, they will all be identified as platform. Not platform Junos, not platform Arista, not platform Nexus, just platform. And how do you do this? You define a function named virtual, where you do this code and say where and when to load this file and under each name. And again, you can use the OS grain lookup and say, hey, if this is a Juniper, load this file and register it under the name platform. And from there on, this is how your module is going to be identified with. Nothing else changes. The code is the exact same. So when you execute you want to invoke the platform module, it's going to execute the code from this module, right? Exactly the same into the version, the same things I've presented earlier. Here's some more explanation. Oh, and also, if you are not loading this module, say, I don't want to load this because this is an Arista switch and I don't care, I don't load it here. Okay, the code is the exact same as previously. And now let's look at the other file for platform_arista, which says if this is an arista, load the module as under the platform namespace, and otherwise don't load it at all. What it does then into the version function is the code we've seen back a few slides for under the arista part of the function. And the same to complete the example and break out that bigger function into smaller functions grouped by platform is for Nexus. Again, if the platform grain is identified as Nexus, register the code from this module under the platform namespace, and the function is appropriately defined. I'm going to switch to my terminal. I'm going to execute platform.version, which indeed gives the exact same output. The idea being that even though the code is physically defined into complete different files, you can execute all of these under the same namespace, for example, platform, as I have in this example. Okay. Excuse me, it's a lot to talk. Now, all these modules we've defined in our own environment, such as example.version, platform.version, and so on, they all are available on the CLI, but not only from the command line. They are available within any salt subsystem you might want to use. For example, you can use them in the template rendering pipeline, into the salt system, into the reactor system, and anything. Once you define it and you are able to execute it from the CLI, they are immediately available anywhere else. Let's take a look at Jinja example template, and let's play with it a little bit. Inside Jinja, you can execute and invoke any salt functions you have available on the CLI. This is a very powerful feature that gives you unlimited resources into your templating. For example, if you want to get the output from one of the functions we defined earlier, so let's say example.version, you can just say salt.example.version and invoke it as a normal function, and then put the output into a variable. And this is about it. You just called that function and you have there its output, just as a normal Python object. Then we can look at the same grains and say if the OS grains is generous, throw out this text. If the grains is EOS, throw out the other text. And what the other text is, okay, maybe it's very unlikely that we are going to have something like that in production, but the idea, just wanted to be something very, very easy to be understood, is that it's going to configure the hostname of your device to include the OS version. You have this template on your devices. This is how you can invoke it. An example, a possibility. There are many other ways. For example, you can use this function net.loadTemplate and say what template to load. So let's do this. Net.loadTemplate and salt-template example.jinja. And I will also append a flag, which is test equals true. I hope you can see my terminal there is just at the very bottom and might bother you. So executing this with test equals true, it does a dry run, so it doesn't actually apply the configuration change on the device. It simply goes to the device, is going to have in a buffer mode or in on Juniper is going to have in the configuration candidate, loads the config, and collects the config diff. As you can see here, you can see this just before you're actually applying, and then discards the configuration because the way I've called the function is with test equals true. It won't actually apply, it just shows what would happen if we are going to do this. So as you can see, in this case, it would change the host name to include the OS version, and similarly with the Junos and EOS. This is again a very powerful feature because it gives you the possibility to manage mixed infrastructure without messing with different syntax. Just execute this and is going to apply it cross-vendor. Now I'm going to execute the same, but without the test equals true flag, which means it's going to effectively change the host name of your device. And now you can see that there's no comment over there. It won't say that the configuration has been discarded. And from now on, those virtual machines actually do have the host name, including the operating system version. Okay, on the slides I have these examples and an output. It would be good if you could do the same as I did. Is anyone that hasn't done this? I'll assume that yes. Okay, and now the final part of the tutorial is just defining and a brief note on how you can use these extension modules you define in your own environment for event-driven orchestration. I have one example which I did have in production at my previous employer, and I aim to have it again, is automatically increasing the BGP prefix limits when one of the sessions triggered the threshold on the maximum prefixes allowed. So when this happens, device is going to complain, it's going to send a notification, usually, I mean, over syslog. For example, using one library named napalm logs, we can process these syslog notifications and transform them into a structured document that is again cross-vendor and respecting the OpenConfig and IETF standards, which you can ingest on the salt bus. Using these events on the salt bus, you can then trigger automatic reactions. So to have the complete picture, the device is going to complain, and Salt is going to be aware that your network device is complaining. And as a response, is going to trigger an automatic prefix limit change. For example, when it matches an event with this structure, saying that, hey, the prefix threshold has been exceeded, it's going to invoke a reactor, which is update prefix limit.sls. The content of this reactor, for example, would be this one, say update prefix limit, this is just title. So you can then identify this is just a human description. So when this is invoked to be able what has been invoked there, and which is calling a function, say syslog.update prefix limits. This function is defined in the same way in your own environment. You define a function like that, syslog.update prefix limit, that implements the business logic you want for your environment. So say I have this device complaining, what am I going to do? Am I going to directly go and apply a configuration change? Probably not. Probably you are going to have some more complex business logic. For example, to say when has been this updated last time, how often it is. Probably don't want to increase unlimited times the prefix limits, or with unlimited numbers.
So is the reactor running like the reactor component, is it like a daemon running on the salt along with napalm loss?
The question was the reactor is running continuously on the salt master. The answer is yes. Behind the scenes is actually just called an engine, which is again, a daemon that is running in background and continuously looking at the event bus and is trying to match the events against the rules you have specified. So it's going to look at every single event, and when it's matching one of the rules, for example this one, is going to say, hey, I match this, I'm going to go and execute this reactor file. Okay, so now to have again a complete picture, when the device is complaining, Salt is going to be aware of this change, the device has, one of the sessions has exceeded the threshold, and then is going to invoke this Salt function you have defined your own environment, and is going to update the prefix limits just behind the scenes. You don't need to do anything else about it. Just Salt is going to deal with it. Just in the end, I want to say thanks to Tessuto for providing us with the Juniper and Arista VMs. If you haven't heard of them, I recommend you to take a look. It's a very cool application. I mean, I've tried to emulate virtual machines myself, and it's quite a complicated topic. And if you don't have resources to allocate full time on something like that, might be a good idea to take a look at it. And for this, before running to have some beers at Beer and Gear, I'll take some questions. Thanks for your attention.
So quick question about the function, right? So is the function, when you said function, are you referring to the external functions? Same thing?
The question was when I'm referring to the function, this one here, if I'm referring to modules, yes. It's a function that you can define in your own environment and to extend along the same ways I've exemplified. Yeah.
So when you run a command on the CLI, do you have a sequence of events that can be printed on the screen when the command is run, similar to Ansible, so that you can debug what is working and what is not working in your entire line of command? Something like verbose added with the command line.
I'm not sure I understand the question.
So, for example, if you run a command to configure a device,
yes,
from your master, so in that case, do you have some functionality like which can help you to print the sequence of events? For example, you're logging in, that is successful, then you're configuring or you're running show commands, that is successful, something of that sort. In case of a failure, like if something is not working, you can at least debug that logging into a device worked, but getting the show version or show IP config did not work, something like that. Can you break things up?
First off, actually there are two questions there. One of the question is if you are able to connect. This is resolved at the proxy startup. I mean, the proxy won't be able to be up if it's not able to connect to your device. This is why at one of the steps I have in those papers, sorry if you didn't have one, was to start the proxy minions in debug mode and to see if it's able to connect. If it's not able, the proxy won't be able to be up, and you won't be able to execute any command. Okay, and the second question is if you are able to log in, but some commands fail, some others don't. Yes, this is going to be shown here. I know. Let me think about something. Let's say something like show fake. It's going to have this here. Let's make it displayed nicer. It's going to have a complete traceback of the failure. Okay. Does that answer the question? Cool.
Hello. Yeah. So this is Prabhu from Juniper. Thanks for your presentation. It was very nice and very helpful. I have a couple of questions. Can this Salt Can this SALT framework can be used to pull the data from a bunch of 100 devices and using netcon for our PC calls and pull the data and put it in a graph so that it can be used as a monitoring tool for a set of devices?
Oh yes, totally. Can be used like that as well, yeah. I mean, from a scalability point of view is no issue at all. I mean, Salt has been run in environments with tens of thousands of devices without any issue, and to collect and aggregate data, as you mentioned, there's something called runner, which is, again, you can write it in the same easy way, just the Python code, you put it in your own environment, which takes the data from all devices, and then you define what you want to define. Is this what you asked?
Yeah, correct. So,
Yeah, so the key word here is runner. Salt runner is a different component of Salt that, again, you can code it in your own environment and extend.
okay. Does it have any hardware dependency?
As in what platforms you can manage?
Yeah.
Yes, it depends on what the community provided. There are many platforms now supported, but not everything. If something is not supported, you identify something that is no support at all. There are two possibilities. If you are using Napalm, you can write a Napalm driver for it. If you go to the Napalm documentation, it's documented how you can extend and write a driver. Otherwise, is to have a Salt proxy module. If you go to the Salt stack docs, you're going to find how you can define a Salt proxy module, and you can put it again in your own environment. As I have here with the extension modules, I have under a directory named underscore modules. You do the same with extending with the proxy module. You'd put it under underscore proxy, and this is about it.
Okay.
Yeah.
Thank you.
So for the templates that you provide, do you provide them for different device types and different versions and all that? And there's a template of how to do that?
If you want your template to depend on different versions as well, yes, you can use here, as I have this example with grains.os that depends on a specific platform. There's another grain named version, which you can access with grains.version and say if it's running this specific version, you can define a different logic. I will show
Okay,
you
and if you create a Napalm template for your device, do you create it as an XML file? Like, are you returning everything as an XML file?
Oh, no. It's just the style format you prefer. For example, in this case, this line here is a set style that this is how I prefer sometimes to configure it. You can also use that curly braces format if you prefer that. So it's flexible enough. You don't need to do anything about it. I mean, behind the scenes, Napalm is going to deal with this and identify the configuration format, and they will just upload it. And just to complete your question, including XML. If you want to write XML, nobody wants. You can do that too, but I prefer set commands, so any of these are supported.
Yeah, I think I'm not asking. So if you wanted to create a template for another device type, like another vendor,
Okay.
right? Then you do it through, you create okay, Napalm gives you a template that you have to fill out for a different vendor's device. Is that how it works?
Oh, no. This is completely on your own environment. This in this example, if you want for, I don't know, for a Cisco IOSXR, you'd have under this line, under this elif, you'd have elif grains.os equals IOSXR, do the other thing.
Yeah, no, I understand that. I'm just saying if you wanted to provide a template for another device type, like, Yeah, another driver, a driver for a different vendor.
Oh, yeah. If it's not available anything yet, there are documents specifying how you can do this in your own environment. And if you go to the napalm.readthedocs.io, is detailed there how you can write your own driver.
Okay. And how is like rollback supported if something fails?
Depends on each platform individually. For Juniper, of course, is there, just there, don't need to do anything else. For example, in Cisco iOS is something very, very complicated because it doesn't have this natively. It just loads a buffer file with your config, and then is going to save it on your device and will reload it again. I'm not an expert on this topic. I haven't worked myself with Cisco iOS. Kirk Byers, he did all of this. It's a lot of work, but somehow he managed it.
All right, thank you.
Yes.
Have you ever run into any issues targeting too many servers at one time with the run assault command? That's one of the issues we've experienced before we have to actually pare down our list to like a subset of what we're trying to hit, and then it's successful. Have you ever experienced anything like that? Instead of hitting like 500 servers at once, we just hit like 50, then hit the next 50, and then the next 50.
Yeah. So the question was if I experienced issues with running against a large number of devices at the same time, right? Okay. The answer is yes. And then you realize that is a configuration issue because firstly, you need to increase the size of the event bus. So, because there's a large number of events, there's a configuration option. I think it's pub_HWM, which controls the high water mark in the 0NQ message bus. With that, you can increase the size of the message bus and how many messages can go through the 0NQ socket. And another thing to keep in mind, I will just go very quickly at the beginning of, oh, not that far. This one. It's here using salt.scale. It's a document that explains different things that you need to be aware when running an environment with a large number of minions. For example, one of the things is batching when you execute against a large number of devices, because you are going to have a large number of events at the same time. Is going to fill up your network capabilities of your server. So you need to execute in batches. So executes the first, I don't know, let's say 50 servers, then next 50 servers, and so on. So you don't have a large number of events incoming at the same time. There are many other examples and good practices in this document explained here. Yeah.
Does this support iOS XR?
It does.
Okay.
Just the XML agent, not yet with gRPC. Hopefully someone will write a driver for it. Okay, if there are no more questions, I guess we should all head to beer and gear. So thanks for your time. It's been a long one.